Hello and welcome back to carboxylic acids and esters. We're going to focus on esters now. In your textbook you're looking at pages 466 to 468. Remember you can get that online, caboodle.com. If you have the booklet, we're on page 7. If you don't worry. Just write the header esters and let's have a look then. The first thing to notice the functional group. So the functional group looks like this, C double bond O, O. Now an ester is a derivative of a carboxylic acid. Hopefully you can see the similarity here. So in the ester, the oxygen there would be attached to another carbon rather than just the hydrogen if it was the carboxylic acid. Now in this topic you're going to get a chance to draw esters and name them. If you're struggling with the naming though and you need more practice, there is a PowerPoint on Connect called Would You Believe Naming Esters, and you can use that to get more practice on how to name them. So esters, oh gosh, there's lots of different types of esters and they can be made naturally and they exist naturally, or we can make them in the lab. They're used for perfumes and flavourings. They're the main uses because they tend to be quite sort of sweet smelling chemicals. And they're made by a process called esterification. So here just showing you an example of the range of different esters that you can find either in nature or you can make them in the lab. So for example, ethyl propanoate would smell like pineapples. There you go. So let's have a look then what esterification actually is. Esterification is a type of condensation reaction. So just pause and have a think. Can you remember the definition for condensation reaction? Press play when you're ready to check what you're thinking and make notes. Okay, condensation reaction then is a reaction in which two small molecules react together to form a larger molecule with the elimination of a small molecule such as water. It's not always water, as you'll see later on, but we'll start with that. Okay, so the word molecule appears a lot there, doesn't it? I'll just give you a minute to make a note of that and I'll see you on the next slide. We're going to teach you 3 ways to make an ester. I'm going to start with the one that you're most familiar with, which is reacting a carboxylic acid with an alcohol. So it's esterification, a condensation reaction. And the reagents, carboxylic acid and alcohol. So this reaction does require a catalyst, and the catalyst is concentrated sulfuric acid. The reaction will happen at room temperature and pressure. You could just mix this in a test tube and eventually you would make the ester, but they're not the ideal conditions. So in the exam, state that you put concentrated sulfuric acid as the catalyst and that you would heat under reflux. Reflux, remember, is the technique, and it's the technique that provides that heat and allows the reaction to proceed without losing volatiles into the lab. Okay, so we're going to look at the equation now, but what I've done is I've videoed me sort of drawing it out by hand, just so that you can, handwritten, just so that you can see what's going on a bit better than just the sort of computer software molecules, if you will. So just pause the video at this moment, and if you can click the hyperlink below, it's on the YouTube channel. If the link won't work, if you just go on YouTube and just search for Sarah Savage Chemistry, you should get that channel that I'm starting to put videos on now. Okay, so just have a watch of that video about writing the equation that's here and then come back and we'll carry on with the notes. Okay. I hope you found that video useful on how to do the condensation reaction, the esterification reaction. So if you're asked to write an equation, then it's always good practice for organic chemistry to show the structure of the molecules. So read the question carefully, do what they ask you to do, but generally speaking, provided you show the structure and it's unambiguous, you're good to go. So if you have a look at this one, then you've got the ethanoic acid and the 2-methyl-propan-1-ol. Oh, there should be a little plus sign there if it's an equation. So those adding together, reversible reaction here. There's your ester and your water. So we're going to have a look at how to name the ester then. So naming the ester, the thing to look for is this. You're looking for the oxygen in the chain, and you want to have a look. Remember what I said in the video, we leave an O on both. We know that that came from the alcohol, and the alcohol is or forms the first part of the name. That's where the first part of the name comes from. So here it was the 2-methyl-propan-1-ol. So we're going to change that to 2-methyl-propyl. The second part of the name then is going to come from the carboxylic acid. So it's not ethanoic acid anymore, it's ethanoate. So if you put those two things together, 2-methyl-propyl ethanoate. And again, if you need more practice on that, you can use that PowerPoint that's on Connect called Naming Esters. So the alcohol gives the alkyl part of the name. The carboxylic acid gives the O8 part of the name. So just pause and have a think now. What would the name of the ester be if we made it from ethanol and pentanoic acid? So just pause, write down what you think and press play when you're ready to check. Okay, so the ethanol would change to ethyl, pentanoic acid would change to pentanoate. You put that together, ethyl pentanoate. Time for a practice then. Your task, write a balanced equation for the formation of this ester and draw the ester using displayed formula. So you can do that on a back page. So you could do the whole equation using displayed formulae, and that way you get to hit both parts of the question. Or you could do the equation using structural formula or skeletal even, and then do the ester showing it is displayed separately. Okay, so just pause and have a go at that and then press play to check your answer. So here the equation, we've just shown it in structural formula just to mix it up a bit. And the displayed formula there for the ester. Okay, so feel free to pause that to just check through that you're happy with that matches what you've done. And it might be a good point here just to take a little break before we look at the next way to make an ester. So just check that you're happy with everything that we've done so far. We're moving on now to the second method to make an ester. It's still called esterification, but this time instead of using a carboxylic acid to react with the alcohol, we're using something called an acid anhydride. So this is a new reagent. So the acid anhydride looks like this, the functional group. Now when I draw it, I'll give it a go using this. I tend to do it this way round. Okay. So you can see that is kind of looking like the makings of a carboxylic acid. Now here that carbon could be joined to a hydrocarbon chain, or it could be a hydrogen. So I'll just stick R there to represent the alkyl group. Now if I was to stick a hydrogen on here, you can see that's your carboxylic acid. But it's not a carboxylic acid we're doing here. So I'm going to carry on from that oxygen. So really that's the centre oxygen there. Okay. So I'm going to carry on with that oxygen and I'm going to go to another C double bond O. And then that would then continue like so. Okay, so those two R groups could be the same or they could be different. So I'll just stick a little prime there just to show that they could be different. Okay, so this is something new. It's called an acid anhydride. It's made from basically reacting carboxylic acids together, and we remove the water. So think about this word anhydride. Okay, it's made from two carboxylic acids that join together by the loss of a water molecule. So we've met the word anhydrous before. So anhydrous and anhydride means no water. So for example, if we had two molecules of ethanoic acid, we can join those together to make ethanoic anhydride. So I've taken this picture out of your textbook. This is at the top of page 467. So you can see on the left there your two molecules of ethanoic acid. We're joining them together to make this anhydride functional group. And notice then on the right as well, there's your water there. So we've removed that water. Okay, now that anhydride is symmetrical because, you know, the R group there in both cases is CH3, so it's a symmetrical anhydride, and it's just called ethanoic anhydride. You will see that you can actually have anhydrides made from joining together two different carboxylic acids, in which case, you know, the R groups would be different, and the naming then we'd have to think about that as well. Okay, so the acid anhydride, it's a derivative of the carboxylic acid. We're going to react it with the alcohol. I'm going to show you how to do that in a moment. And it's the second method to make the ester, and we'll have a look as to why it's an alternative method, what the advantages are. Okay. Let's describe then making an ester using an acid anhydride with an alcohol. So the reaction is still called an esterification reaction. It's a condensation reaction. The reagents then, the acid anhydride with the alcohol, and the conditions are dry. So think about that anhydride is without water. So just like we did for the first way of making an ester, if you can have a look at the video on YouTube, so click on the hyperlink or search Sarah Savage Chemistry on YouTube and have a look at this one, ethanoic anhydride and methanol. So it's probably easier if you watch me write it out by hand so that you can see what's going on. As you watch the video, you might want to pause it throughout and make your own notes so that it makes sense to you rather than just watching it. You know, you could replicate that on paper as well. Okay, and once you've done that, come back and we'll carry on with the next slide. I hope that video was helpful and you could see what was going on. So I'll reveal then the equation here on the PowerPoint. Okay, so there's our ethanoic anhydride with our methanol, and we've got our ester with our carboxylic acid. So if I try to highlight then, so remember we've chopped that H off. If we take, probably easier to take this one here. Okay, so basically we've joined up those bits, and then if I can highlight that H then has just gone on the end of that O there. Okay, so we've ended up making two organic products. One of them is the ester, so recognising that functional group there, and then the other one. Because there's a H on the end, it might look like an ester at first, but that then is making that into your carboxylic acid. Now the big difference here is this arrow. Okay, the arrow is just going in one direction, and that is one of the advantages of using the anhydride instead of the carboxylic acid. Okay, so the advantages to this method then are the fact that you get better yields because it goes to completion. It's not in equilibrium, it's not a reversible reaction, it goes to completion, so you get a better yield. It's also a bit more reactive, so you don't need a catalyst and you don't really need to heat it up. So no heat required, no catalyst required, and better yield, they're your advantages. Time for a practice then. So your task is to write an equation for the reaction between propanoic anhydride and ethanol, and you're asked to name all of the products made. So if you've got your booklet, you can answer this on the back page. So the name of the anhydride has changed, propanoic anhydride. So think back what the ethanoic anhydride looked like and see if you can work it out. Okay, so pause the video or PowerPoint, give it a go, and then press play when you're ready to check your answer. Okie dokie, so here's the equation. Notice the reaction is just going in the forward direction, so it's not reversible. That's the one of the main advantages, that it'll give a better yield. So let's just try and make sense of what's going on. So using our mantra, leave an O on both, we're going to chop the bond here between the oxygen and the hydrogen. And so for our ester functional group, we need a C double bond O next to an O. So there's our O. The C double bond O, then if we choose this one here, it didn't matter if we chose that or the one next door because the anhydride is symmetrical, but we'll choose that one, and we're going to therefore break the bond there. Okay, so we're going to join this bit up to this bit to get our ester. So here it is underneath. Okay, so hopefully you can see what's gone on there. Right, the bits that are left then, so the hydrogen from over here, and basically this big chunk here, so the bits that are circled at the top, that's what's going to make your your acid at the bottom. Okay, your carboxylic acid. We just put that H on there. So to name those products then, the carboxylic acid, you've got 3 carbons, so that's propanoic acid. The ester then, the oxygen to the right, there's 2 carbons, so that will be ethyl, that came from the ethanol, and then there's 3 carbons for the propanoate. So the ester, ethyl, propanoate, and the carboxylic acid is propanoic acid. Okay, so hopefully you got that okay. It does take a little bit of practice. Just watch out, I'll give you a bit of a heads up. I think from memory, one of the homework questions has got this reaction, and I'm pretty sure that we're a bit sneaky and we use an anhydride that's not symmetrical. Okay, so you've got to think carefully there. That'll challenge you a little bit as to the types of products that are made. Okay, but for the time being, we've seen it there, esterification using an anhydride and an alcohol. Okay. Time to pause to check your progress using the learning outcomes on the front cover of your notes. Remember, these are the points from your exam board specification. So far then you should be able to describe the esterification. Now when we say describe, really you need to be able to do balanced equations and showing the reagents and the conditions for the reaction. So the first method then was using carboxylic acids with alcohols in the presence of an acid catalyst, for example conc H2SO4. remember that reaction is in equilibrium and the conditions are heat under reflux. The second method to make an ester, you can use the acid anhydride instead of the carboxylic acid. So acid anhydrides with alcohols. For that reaction, remember, you don't need to add a catalyst and you don't need to heat it up, and it will give you a better yield because that reaction goes to completion. So before you move on, just make sure you're comfortable with those two methods. Make sure that you can do the balanced equations for them. The acid anhydrides may take a bit more practice. We're going to move on now to a third way to make an ester, and that's using another carboxylic acid derivative called an acyl chloride. We're just going to introduce those in this PowerPoint because there is a third PowerPoint called acyl chlorides where we'll look at them in more depth. But for the moment, we'll just introduce how to make esters from acyl chlorides with alcohol. Acyl chlorides. So an acyl chloride's functional group looks like this, C double bond O, Cl. And we make the acyl chloride from the carboxylic acid. So you start with a carboxylic acid, you react it with something called thionyl chloride. Now we'll look at this in more detail in the next PowerPoint or video. That's all about acyl chlorides. For now, we're just introducing them because it's going to give us our third way of making the ester by reacting it with the alcohol. If you have the booklet, we're on page 10. Esterification then using an acyl chloride with the alcohol. Because acyl chlorides are more reactive than the carboxylic acids, we don't need a catalyst and we don't need to heat it up. So we can do this reaction at room temperature. As usual, there's a video on YouTube there. If you click on the hyperlink to watch the video, feel free as you watch it to pause and make notes. So it's just developing the equation there for the reaction between ethanoyl chloride, which is your acyl chloride, and the propan 1-ol. I hope you found the video useful to see how the acyl chloride reacts with the alcohol. So looking at the equation then again, just to recap, so we're looking at breaking the carbon-chlorine bonds, so the chlorine from here will react with the hydrogen from the alcohol and we've formed HCl. So think back to your original definition of the condensation reaction. It finished with the elimination of a small molecule such as water. So here we can see it's in fact HCl. Okay, the organic bits from each molecule then join together to make our new functional group, which is the ester, C double bond O, and then next to an oxygen. And it's that oxygen that you look for when you start to name the molecule. So find that oxygen first of all. If we move away from that on the hydrocarbon chain, that's the first part of the name, so that will be propyl. Now remember, if that propyl wasn't there, this whole bit here, think back to your carboxylic acids bit, that would have been ethanoate. So that's the second part of the name, so propyl ethanoate for the ester, and the small molecule is the hydrogen chloride. Time to pause and check progress again using the learning outcomes from the front cover of your notes. So you should be able to describe the esterification. Now, when we say describe, that command word in this context, we're looking for, can you name the reagents? Can you tell us the conditions? So state the conditions. And can you write balanced equations? Now, when we do the balanced equations for esterification, because it's an organic reaction, it's wise to use structural, skeletal or displayed formulae. Don't just use molecular formulae because we need to see these functional groups and we need to see the functional groups changing. And they often ask you in the question anyway to show the structure of the product. So why not do the whole equation showing the structures and then you won't miss those marks. So when we say describe, it's reagents, conditions, and equations. You may also be asked to name the ester. Now, don't name molecules unless they ask you to. If they ask you to identify the molecule, it's good enough just to draw it. So that's the safest way. Because if you draw it correctly and then name it incorrectly, you're contradicting yourself and you could lose the mark. So only name it if they ask you to, but you are supposed to be able to do that. So practice that skill of naming esters as well. Now we've shown you 3 ways to make the ester. So just to remind you then, you've got carboxylic acids and alcohols, acid anhydrides and alcohols, and you've just seen the acyl chlorides with alcohols. Notice in bold there, alcohols. So each method, you've got alcohol there. You're just changing what you're reacting it with. The original one was with a carboxylic acid. The other 2 are carboxylic acid derivatives. So if I was you, I'd pause the video or PowerPoint at this point, make perhaps a summary table of those 3 different types, highlight the differences. So for example, with the first one, what was the small molecule? What type of a reaction was it? What were the conditions? Okay, for the second one, can you remember what the small molecule was when you use an acid anhydride, and so on? Okay, so do a little summary table and be prepared to be able to do balanced equations for any given alcohol and carboxylic acid and so on. Make use of your textbook as well, the pages 466 to 468. There's going to be a few more examples in there. There might be some questions as well for you to practice. So just have some time to consolidate your knowledge so far. When you come back, we're going to look at hydrolysis of esters. So now we've taught you to make the ester, we're going to have a look at how you break the ester back down into the reactants. Okay, and when we do so, we'll just make the carboxylic acid and the alcohol again. All right, so stop it, have a pause, and come back when you're ready for the next bit. Moving on then to hydrolysis of esters, we're on page 11 of your notes. So there are 2 methods here, and it's all to do with the catalyst that we use. You can either use an acid or an alkali, and it's really important that you look for that in the exam question, because the products made will differ depending on the type of catalyst that you've used. So we'll go through each one in turn. We'll start first of all with the acid catalyzed hydrolysis. So hot aqueous acid hydrolysis. The acid of choice here to quote would be HCl. The state symbol is important, we'll see why shortly, but a clue there is in the title, it's the breakdown in the presence of water. So think about that. The conditions then, we do need to heat this up, and the usual technique then is going to be heating under reflux. So there are your conditions. So if we start with an ester, let's choose a random one, so methyl propanoate. There's a video here for you to watch again, so click on the hyperlink, it'll take you to the YouTube channel. Watch the video of this reaction being drawn out, make notes as you like, and then we'll summarise on the next slide. So looking at the equation then, so don't worry about the shape of the organic molecules there, that's just the way ChemDraw has drawn the molecules here. As long as they're all connected correctly, that's fine. So you've got the ester, the methyl propanoate, and we've got that water breaking the ester bond, putting the water back to give us our carboxylic acid and alcohol. So just make sure that you do put the AQ sign on the catalyst to provide you with that water. So your products then, when it's an acid catalyzed hydrolysis, is the carboxylic acid and the alcohol. The second method then is using an alkali as the catalyst. So it's hot aqueous alkaline hydrolysis. You may see it referred to as saponification, that's the name of this process. The reagents then, your ester with the strong alkali sodium hydroxide. It could be given to you as potassium hydroxide, but the AQ symbol is essential. We need to heat it up, so heating under reflux for your conditions. And we'll stick with the same ester, so methyl propanoate. And again, there's a quick video clip on it, how to write the equation. There's a little bit more to this one, so you'll see that in the video. Again, feel free to pause it and make notes, and then we'll summarise it on the next slide. So if you're asked for the products of hydrolysis of an ester, you need to check which catalyst it is, acid or alkaline. If it's alkaline, you end up with the salt of the carboxylic acid and the alcohol. So just back to that saponification, that's the name, the traditional name, if you will, of the process of this reaction. And this is actually making soap. So the salt of the carboxylic acid, if it's a long chain fatty acid, so that'll have come from esters in oils and fats. They would react those with the sodium hydroxide to hydrolyze them, and those salts of the long chain fatty acids, that's actually soap. So if you've ever heard of Lever Brothers, or if you've heard of Port Sunlight on the Wirral, they used to make that there for a long time, in fact up until about 2001 I think. So yeah, a bit of history for you there. So if you've never been to Port Sunlight, go, thoroughly recommend it. Okay, so a bit of history there for you for chemistry. So yeah, I'm waffling, I'll carry on. So you've got the salt of the carboxylic acid and the alcohol. So you can see how it's different to the acid catalyzed one. And remember what I said in the video, this is the equation that they're after in the exam, but the video hopefully showed you where that came from. Okay, so yeah, the products are different to the acid catalyzed. You still get the alcohol, but instead of the carboxylic acid, it's the salt. So here, sodium propanoate would be the name, but remember, don't name it unless they ask you to. Time to pause and check progress again. So use your learning outcomes on the front cover of your notes. These are your spec points. So this section has all been about the hydrolysis of esters. Again, that keyword there, command word, describe. So we need to know the reactants, the conditions, any catalysts, and the equations. And remember, when you do equations, you're showing the structure so that you can see the functional groups changing. So remember, there's two ways to hydrolyze the ester. Depending on the catalyst that you use, that will dictate the types of products that you make. So if we use an acid catalyst, you get the carboxylic acid with the alcohol. And if you use the alkali catalyst, then you get the carboxylate salt and the alcohol. So make sure you've got those clear in your mind. The best way, of course, to keep that in your head is to practice some questions. So there's a couple coming up now. They're on page 11 in your notes. So play this PowerPoint to the end and only reveal the answers once you've had a go at those questions, and you can check your work then. Okay. Any problems with it though, do ask your tutor and they'll help you if you're a bit stuck. All right then, so on part 3 we're going to look a little bit more detail about acyl chlorides, and that'll bring this topic to a close. Okay, so I'll see you in part 3. So here are the practice questions for the hydrolysis of esters. Give them a go, press pause now, and then just press play again when you're ready to check your answers. Good luck.